Hi and welcome to this segment where I would like to solve the quadratic equation by completing the square. So an expression such as x squared or x plus 3 squared, or let's say x minus 3 squared, is called a perfect square. Okay, if for instance x squared is equals to 9, to get the value of x we simply take the square root on both sides, and then we find that the value of x is plus or minus square root of 9, which is 3. Okay, if x plus 2 squared is equal to 5, then we take the square root on both sides, and then maybe I don't have to write that now, and then we can say that x plus 2, the square root of 5 is plus or minus 5, for which we can say that x equals to negative 2 plus or minus 5. Therefore one value of x is going to be minus 2 plus 5, and the other value is going to be minus 2 minus 5, so that we have this as 3 and this as negative 7 as the two values of x. Now, if a quadratic equation is arranged or is rearranged so that one side of the equation is the perfect square and the other side of the equation is a number, then the solution is readily obtained by taking the square root on both sides, as we have already seen in these examples. The process of rearranging one side of a quadratic equation into a perfect square before solving is what we call completing the square. For instance, if we have this, we know when we expand, okay, x plus a into x plus a, then we should be able to get x squared plus 2ax plus a squared. Okay, now in order, you realize that in order to make the expression x squared plus 2ax into a perfect square, then it is necessary to add half the coefficient of of x, and then we square it. So you see that if we started with this expression here, only this expression, to make it a perfect square we add a squared, but a squared is half the coefficient of x squared. The coefficient of x is 2a, so when we have it and we square it, we get the term which we add here to make it a perfect square. Let us look at an example. We have the example. We have the term x squared plus 3x. To make it a perfect square, we have said we are going to add half the coefficient of x, which is 3, and then we square. Okay, so what we have now here is x squared plus 3x plus 3 over 2 squared, that is going to be 9 over 4. So this one here is a perfect square here. Okay, this what we have here is a perfect what? Square. Indeed, this you can reduce, okay, to x plus 3 over 2 squared. So the trick here, when you have reached, as long as you have done this correctly here, then the trick here to write it as just a perfect square, you just take the term here x, you look at the term here x, and then the term here 9 over 4, and you write 9 over 4 in the form 3 over 2 squared. So what I'm trying to say is you just pick this term here and this term here. Okay, the terms which are inside the square, the square sign, that is x plus 3 over 2 squared. Indeed, if you expand x plus 3 over 2 squared, then you should be able to get the x, and the x will give us x squared. Then let us do the outer terms here. This and this will give us 9 over 4, and then the inner term, this and this, will give you 3 over 2x, and then we have this and this, which is 3 over 2x. So we'll have x squared, then 3 over 2x plus 3 over 2x should give us 3x. Okay, that is 1.5, and 1.5 gives us 3, and then plus 9 over 4. Okay, good. Now that we have an idea how to do that, let us see how we can solve now a real quadratic equation. So we would like to solve, let us pick an equation here. Okay, maybe we can start with that one. Exactly, if we wanted to solve the equation 2x squared plus 5x plus 3 equals to 0, then all we have to do is to leave all the terms in x on one side, and then take the constant outside. Next is try to complete this square here, which we have seen. Just a minute. Before we actually complete this square here, I skipped one thing. We have to make that the procedure which I've showed you only works when the coefficient of the square term is unity. Okay, so all the examples we are dealing with, actually the previous example here, the coefficient of the square term is unity, it's 1. So that is one thing that we should not forget, and that I had actually forgotten here. So 1 is, okay, this is the equation which you want to solve. So 1 is to make this unity. Okay, so how do you make it unity? We divide through by 2, so that you have x squared plus 5 over 2x plus 3 over 2. We divide all sides by 2 for consistency, but the right hand side still remains 0. Then 2, we only remain with the terms in x. Okay, and then take this other constant on the right hand side. Then 3, we complete this square here by adding half the coefficient of x. The coefficient of x is 5 over 2, so we are going to get half of it, and then we square it, and then we add it. But this time round, since we have an equation, for consistency, what we do on the left hand side, we also have to do on the right hand side. Therefore, we are going to get x squared plus 5 over 2x, and then the extra term we are adding, we are saying is half the coefficient of x, and then we are squaring it. Now for consistency, we have said that we have to do the same on the other side, so please allow me just to write it. Since I don't have lots of space, it is already 5 over 4 squared. Okay, so let me just write it here in simplified form. 5 over 2x plus 5 over 4 squared equals to negative 3 over 2 plus 5 over 4. Well, we can simplify this side. This is 25 over 16. So we have already seen the trick in the previous example, that if we have done everything properly, we just take this term x and this term, the terms inside the square signs. So we have that this is the same as x plus 5 over 4 squared, and then on the right hand side here, okay, now we have to simplify this. Negative 3 over 2, the LCM is 16, so we can say this is the same as what, this is over 2, so times 8, this is 16, and then I multiply by 8 to get 24. I hope if I haven't made any mistake, it should be that maybe 1/16. If I've made a mistake, please be sure to check it out. So I suppose that if I add this to that, so we have 1/16, and then now we can take the square root on both sides, so that now we have x plus 5/4 equal to plus or minus square root of 1/16 is 1/4. So that x is going to be equal to the first, okay, minus 5/4 plus or minus 1/4, and then now we have that one value of x is going to be minus 5/4 plus 1/4, or the other value is going to be minus 5/4 minus 1/4, and then this is going to be 4/4, or negative 4/4, which is -1, or this value is negative 6/4, which is going to be negative 3/2. If I haven't made a mistake, those should be the values. If I have made a mistake, I think I actually have made a mistake. I don't like this. I really don't like this. I think the mistake is made here, because okay, somebody help me see where the mistake is. Let's see, this is -3 divided by 2. Okay, let me see. Oh, I think the mistake may have been in how I wrote the equation. So the equation here, let me cross check please. Yeah, this is 2x squared plus 5x minus 3 equals to 0. 2x squared plus 5x minus 3. Oh, okay, again. So okay, the answers, I believe, the answers that we have got in this video here are consistent with the equation we have here. Okay, we should substitute them and make sure that they satisfy that. However, in the actual example in the book is that plus 5x minus 3 equals to 0. So the mistake I made was here. So when it is minus 3, of course the solutions will be different from what we get here, and that was kind of confusing me. However, it is the same idea. Please follow through the same steps. Make the coefficient unity, then complete the square by adding half the coefficient of x to both sides of the equation for consistency, and then you shall have this factorized form, and then take the square root on both sides and do the algebra. And always remember to work out the correct equations, and not make up your own equations like I do here. Okay, thank you, and see you in the next video.